considering this set here, we know that this is, we've been told that this is a geometric sequence. So that means that every term is obtained by taking the previous term and multiplying it by some number called the common ratio. I'll call it 2 times r. That means this next number is that previous times another r, which is 2r squared. And this 128 then would be that times another r, or 2r cubed. So I then know that whatever my common ratio is, it satisfies this equation, 2r cubed is equal to 128. Well, now I'm going to solve for r. We can divide both sides by 2 to get rid of this 2 right here. And that gives us 64 is equal to r cubed. Now I need to get rid of an exponent. And the opposite of an exponent, or the inverse operation is what it's called, is a root. And so we're going to do the third root, or the cube root, of both sides here. So the cube root of 64 is equal to r. In other words, the cube root of 64, that's the number that if we can multiply it by itself 3 times, we get 64. And that number is 4. So our common ratio here is 4, which means that this 2r is actually 8, and 2r squared is 32. The explicit equation now, I'm just doing a geometric sequence. I know that y is obtained by taking the first term, 2, multiplied by the common ratio, 4, raised to the x minus 1. The recursive equation is, to get our y value at a given x value, we take the y value at the previous x value, and we multiply by our common ratio, which is 4. So this is multiplied by 4. And of course, with a recursive equation, we always want to give a starting value, y at 1, when x is 1, is equal to 2, that first value.